Coming back to test hint number 17, which says, complete a balanced single replacement reaction when you're given the reactants. And you're going to see several questions like this where we will have the chemical formulas of the reactants and then an arrow and nothing. And you have to figure out what it is that's going to happen. So, in a single replacement, one new element is going to come along and kick out something that's in the compound that's there.
Right.
That was the dancers thing, that was the iron and copper sulfate lab, and so on.
Right.
And all of that is based on that activity series that we mentioned before. So there are some reactions where the new element coming along isn't able to kick out something in the compound.
Right.
If you throw a chunk of gold
Right.
into
Just about anything.
right, a solution. I mean, gold is shiny and pretty, and it stays that way at the bottom of the ocean and treasure chests for a long, long, long time because it's not very reactive. So it's not going to be able to kick something out. It's really low on the activity series. But if you did that with, say, sodium,
which is pretty high on the activity series.
high on the activity series, really reactive, we saw that happen earlier in the year, then sodium is the kind of element that could kick something out.
Absolutely.
Say water or an acid or something like that. So think about that, and take a look at your activity series and perhaps where the elements in question are on the periodic table.
Number 18. Predict the products of a double replacement reaction given the reactants. Well, there it was.
Right.
We just did that. We gave you these. You had to predict this. By the time the test comes around, you will have done this problem or these kinds of problems predicting products several times.
Right, and again, back to our acid and base lab, lab 15, you wrote those over and over and over and over and over again and over.
We can do this next set, 20 through, well, 19, 20, 21, all kind of the same sort of question, but we have lots of choices. We have 5 significant reaction types we can throw at you, and you've got to be able to identify them.
Yeah, and we wrote some up here. We have an example of everything and one of them twice. So this one, of course, must be what?
That one is synthesis.
Synthesis.
Or combination.
Composition.
Yeah.
Because little things are coming together to make one big thing.
Right.
And it's opposite.
This would be decomposition, because we're taking a complex compound, only one reactant, and breaking it apart into simpler substances.
Right. Here we have a single replacement reaction because there's a lone element coming along and kicking something out of a compound, taking its place, leaving the other substance there. That's, again, the iron and copper sulfate lab. We have 2 here that are...
These 2 are both double displacement reactions. This one is an acid and a base, so it's a neutralization reaction, but...
Same? Still double displacement.
It's still double displacement. And this is your typical double displacement where you have 2 aqueous salts reacting together, and then you've got your combustion down below. Right.
And I think the only thing we haven't really mentioned about our double displacements yet is the solubility chart, where when we're predicting a product, because you have several different questions here, when you're predicting a product in a double displacement, you want to go to the solubility chart to see if a solid precipitate is going to be one of the 2 possible things that it forms, and then you're really, really sure that that reaction happens. Other reactions.
Or you might see actually written in the reaction could be an AQ here, an AQ here. This might have an S after it, which would indicate it is a solid. It's one, and then this would be another AQ. The point is that 2 solutions react to produce a solid. That's going to be your double displacement reaction.
Okay, so
22.
You're going to have some of these different kinds, and you have to tell us what kind they are. That's 19, 20, 21. Know your reaction types. Know what an example of those would look like. There's a nice chart in your book to help you with that as well. And then 22.
Identify the balanced equation, given the word equation.
Okay, that's very similar.
Or given the word description of the reactants.
Right. So this will take one of the types And again, they'll tell you what products are, what reactants are being put in, and you need to then think about, okay, these are the kinds of products that would form in this kind of reaction, and then identify the correctly balanced equations. You're going to have to look for subscripts written correctly, and then coefficients put in correctly, kind of ties it all together.
Yes.
But there's not too terribly much we can change up to throw at you, because it's just many examples of these 5 kinds of reactions,
Right.
and counting atoms on the left and right. So,
23?
23.
Sure, identify the driving force, why a reaction occurs in a double replacement reaction.
That's kind of foreshadowed
Yeah,
there.
this solid, the production of this solid is the driving force that makes that happen. Once the correct ions come in contact with each other, you mix this solution with this solution, whoosh, these two ions immediately start to combine and pull that reaction along with it.
Right. And in the next chapter 2, you're going to see some pretty cool looking reactions like that when we do throw the stoichiometry. So that takes us to the short answer.
Yep. All right, 24 through 30. All righty.
Okay, 24 is balancing an equation given the skeleton equation. And this will be a generic example.
Very generic.
And something that common sense should help you figure out.
Yes.
So let's move on.
Okay,
25. Okay, now I'm glancing at the page here, and I see in all of these, reactants are given, products are not. So they're all predict the product and state what kind. So go back to the types. If you have 2 small things coming together to make one, it's synthesis or combination. If it's one substance turning into 2 or more smaller things, it's decomposition. There will be several different examples. We must have at least one of each kind on here.
Because there's 5.
Yeah, and
there
a
are
couple.
5 that are blank.
And just know how to write those chemical formulas correctly. I really think they need to go back to chapter 9 and spend some time with Monster again. Go back and look at the resources we have posted on Moodle for you. You know, it doesn't make sense for us to stand here and do 20 bazillion examples, because you already have access to that with the links that we have posted for you and all the worksheets and things we've been giving you. We've been practicing this over and over and over, but you absolutely must know what kinds they are, be able to state the names, and identify the products, write all the subscripts correctly, and then balance.
Right. We're taping this roughly a week before the test.
Right.
And there's a few dedicated motivated students that are going to access this very early on. And you need to ask questions. You're going to have you will have been presented a tremendous number of opportunities to get some valuable experience and get some good feedback. Ask those questions. Even if you're only seeing this on the day before or 2 days before the test, you need to ask these questions and get yourself pointed in the right direction. A little too late is still better than nothing.
Right. And I'd suggest too the pop-up podcast things, because that we have in the extra help section, because he gives you a short little explanation and then does several examples.
Yes.
So you might be able to get by with watching just a couple minutes of his video. You might need to watch, 5-10 minutes of the video
and
to practice some examples. And
look for pencasts that pop up here in this last week to guide your practice.
Awesome.
All right.
Good luck. Happy studying.
Good chemistry.